Is that Python code of yours running a little slow? Are you thinking about rewriting the algorithm or maybe even in another language? Well, before you do, you'll want to listen to what Davis Silverman has to say about speeding up Python code using profiling. This is show number 28, recorded Wednesday, September 16th, 2015.
I'm a developer in many senses of the word, cause I make these applications, but I also use these verbs to make this music. I construct it line by line, just like when I'm coding another software design. In both cases, it's about design patterns. Anyone can get the job done, it's the execution that matters. I have many interests, sometimes it conflict.
Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm and follow the show on Twitter via @talkpython. This episode is brought to you by Hired and CodeShip. Thank them for supporting the show on Twitter via @hired_HQ and @CodeShip. There's nothing special to report this week, so let's get right to the show with Davis. Let me introduce Davis. Davis Silverman is currently a student at the University of Maryland working part-time at the Human Geo Group. He writes mostly Python with an emphasis on performant Pythonic code. Davis, welcome to the show.
Hello.
Thanks for being here. I'm really excited to talk to you about how you made some super slow Python code much, much faster using profiling. You work at a place called the Human Geo Group. You guys do a lot of Python there, and we're going to spend a lot of time talking about how you took some of your social media sort of data, real-time analytics type stuff, and built that in Python and improved it using profiling. But let's start at the beginning. What's your story? How did you get into programming in Python?
I originally, when I was a kid, obviously, I grew up and I had internet. I was lucky, and I was very into computers, and my parents were very happy with me building and fixing computers for them, obviously. So by the time high school came around, I took a programming course, and it was Python, and I fell in love with it immediately, and I've since always been programming in Python. I've been programming in Python since sophomore year of high school, so it's been quite a few years now.
I think all of us programmers unwittingly become like tech support for our families and whatnot, right?
Oh yeah. Oh, my entire family. I'm that guy.
Yeah. I try to not be that guy, but I end up being that guy a lot.
Yeah.
So you took Python in high school. That's pretty cool that they offered Python there. Do they have other programming classes as well?
Yeah. So my high school, I live in the DC metro area. I live in Montgomery County. It's a very nice county, and the schools are very good. And luckily, the intro programming course was taught by a very intelligent teacher. So she taught us all Python. And then the courses after that were Java courses, the college level advanced placement Java, and then a data structures class after that. So we got to learn a lot about the fundamentals of computer science with those classes.
Yeah, that's really cool. I think I got to take BASIC when I was in high school, and that was about it. It was a while ago.
I wrote a BASIC interpreter, but it wasn't very good.
Cool. So before we get into the programming stuff, maybe you could just tell me, what is the Human Geo Group? What do you guys do?
Yeah, so the Human Geo Group is we're a small government contractor, and we deal mostly in government contracts, but we have a few commercial projects and ventures that I was working on over the summer that we'll be talking about. We're a great small little company in Arlington, Virginia, and we actually just won an award for one of the best places to work in the DC metro area for millennials and for younger people.
If you go to thehumangeo.com, you guys have a really awesome webpage. I really like how that is. It's like, bam, here we are. We're about data, and it just has kind of this live page. So many companies want to get their CEO statement and all the marketing stuff and the news, and you guys are just like, look, it's about data. That's cool.
Yeah, there was a recent, I don't remember how recent, but there was the website rewrite, and the website, this one guy, he took the time, and he's like, I really want to do something, show some geographic stuff. So he used Leaflet.js, which we do a lot of open source with, and on our GitHub page with Leaflet.js, and he made it very beautiful, and that even there's some icons of all the people at Human Geo, and I think it's much better than any of those, like you said, a generic contractor site. It's much better and much more energetic.
It looks to me like you do a lot with social media and like sentiment analysis and tying that to location, the geo part, right? And all that kind of stuff. What's the story there? What kind of stuff do you guys do?
Yeah, so what I was working on was we took one of our customers is a $1 billion entertainment company, and you've probably heard of them. I think we talk about them on our site. And what we do is we analyze various social media sites like Reddit and Twitter and YouTube, and we gather geographic data if available, and we gather sentiment data using specific algorithms from things like the Natural Language Toolkit, which is an amazing Python package. Then we show it to the user in a very nice website that we have created.
So you say you work for this entertainment company as well as like a government contractor. What is the government interested in with all this data? The U.S. government, that is, right? For the international listeners.
Yeah, it's definitely a United States government. We do less social media analysis for the government. We do some, but it's nothing. It's not what people think the NSA does. Definitely, I think just like anything like a company would want, you'd search on something, and then it would have there are Twitter users talking about this in these areas.
Yeah, I guess the government would want to know that, especially in like emergencies or things like that, possibly, right?
Yeah, we also do some platform stuff. Like we create certain platforms for the government. That's not necessarily social media stuff.
Right, sure. So how much of that is Python and how much of that is other languages?
So at the Human Geo, we do tons of Python at the back end. For some of the government stuff, we do Java, which is big in the government, obviously. So I think we definitely do have a lot of Python. We use it a lot in the pipeline for various tools and things that we use internally and externally in Human Geo. I know that the project that I was working on is exclusively Python in all parts of the pipeline for gathering data and for representing data for the back end server and the front end server. So that was all Python. Right.
So it's pretty much Python end to end, other than it looks, I don't know specifically the project you were working on, but it looks like it's very heavy, like D3 fancy JavaScript stuff on the front end for the visualization. But other than that, it was more or less Python, right?
We do use a lot. We do have some amazing JavaScript people. They do a lot of really fun looking stuff.
Yeah, you can tell it's a fun place for like data display, front end development. That's cool. So Python 2 or Python 3?
So we use Python 2, but I was making sure when I was working on the code base, I was definitely writing Python 3 compatible code using the proper future imports, and I was testing it on the Python 3, and we're probably closer to Python 3 than a lot of companies are. We just haven't expanded the time to do it. We probably will in 2018 when Python 2 is nearing end of line.
That seems like a really smart way to go. Did you happen to profile it under CPython 2 and CPython 3?
I didn't. It doesn't fully run in CPython 3 right now. I wish I could.
It would just be really interesting since you spent so much time looking at the performance, if you could compare those. But yeah, if it doesn't run...
That would be interesting. You're right. I wish I could know that.
I suspect that most people know what profiling is, but there's a whole diverse set of listeners. So maybe we could just say really quickly, what is profiling?
Yeah, so profiling in any language and anything is knowing heuristics about what's running in your program and, for example, how many times is a function called or how long does it take for this section of code to run. And it's simply like a statistical thing. Like you get a profile of your code, you see all the parts of your code that are fast or slow, for example.
You wrote a really interesting blog post, and we'll talk about that in just a second. And I think like all good profiling articles or topics, you sort of point out what I consider to be the first rule of profiling, or more like the first rule of optimization, which profiling is kind of the tool to get you there, which is to not prematurely optimize your stuff, right?
Yeah, definitely.
Yeah, I've spent a lot of time thinking about how programs run and why it's slow or why it's fast, or worrying about this little part or that little part. And, most of the time it just doesn't matter. Or if it is slow, it's slow for reasons that were unexpected, right?
Yeah, definitely. Yeah, I always make sure that there's a legitimate problem to be solved before spending time doing something like profiling or optimizing a code base.
Definitely. So let's talk about your blog post, because that kind of went around on Twitter in a pretty big way and on the Python newsletters and so on. And I read that, like, oh, this is really cool. I should have Davis on and we should talk about this. So on the Human Geo blog, you wrote an article or post called Profiling in Python, right? What motivated you to write that?
Yeah, so when I was working on this code, basically my coworkers, my boss, they said, this piece of code, we have this pipeline for gathering data from the customer specifically that they give us, and we ran it about at like 2 a.m. every night. The problem was it took 10 hours to run this piece of code. It was doing a very heavy text processing, which I'll talk about more later, I guess. It was doing a lot of text processing, which ended up taking 10 hours. And they look at it and they said, it's updating at noon every day and the workday starts at like 9. So we should probably try to fix this and get it working faster. Davis, you should totally look at this as a great first project.
Here's your new project, right?
Yeah. It's like, here's day 1. Okay, make this thing 10 times faster. Go.
Yeah. Oh, is that all you want me to do?
Yeah. So I wrote this and I did what any guy would do. First thing I did was, profile it, which is the first thing you should do to make sure that there's actually a hotspot. And I ran through the process that I talked about in the post. I talk about what I ran through, the tools I use. And I realized that it wasn't a simple thing for me to do all this. I don't do this often. And I figure that a lot of people, like you said, maybe don't know about profiling or haven't done this. So I said, if I write a blog post about this, then hopefully somebody else won't have to Google like 20 different posts and read all of them to come up with one coherent idea of how to do this in one fell swoop.
Right. Maybe you can just lay it out like, these are the 5 steps you should probably start with. And, profiling is absolutely an art more than it is, engineering, but at least having the steps to follow is super helpful. You started out by talking about the CPython distribution, and I think it'll be interesting to talk a little bit about potentially alternative implementations as well, because you did talk about that a bit.
Yep.
You said there's basically 2 profilers that come with CPython, Profile and cProfile.
Yeah. So the 2 profilers that come with Python, as you said, Profile and cProfile, all have the same exact interface and include the same heuristics. But the idea behind Profile is that it's written in Python and is portable across Python implementations, hopefully. And CPython, which is written in C, and is pretty specific to using a C interpreter, such as CPython or even PyPy, because PyPy is very interoperable.
Right. It does have that interoperability layer. So maybe if we were doing like Jython, or we were doing IronPython or Python or something, we couldn't use cProfile.
Yeah, I wouldn't say that you can.
I'm just guessing. I haven't tested it.
I would say that you would use for Jython and IronPython, you could use the standard Java or .NET profilers and use those instead. I'm pretty sure those will work just fine because they're known to work great with their respective ecosystems.
Do you know whether there's a significant performance difference? Let me take a step back. It seems to me like when I've done profiling in the past that it's a little bit like the Heisenberg uncertainty principle, in that if you observe a thing, by the fact you've observed it, you've altered it, right?
Definitely.
When you run your code under the profiler, it might not behave in the same exact timings and so on as if it were running natively. But you can still get a pretty good idea, usually, right? So is there a difference across the C profile versus profile in that regard?
Oh, yeah, definitely. Profile is much slower and it has a much higher latency and has overhead, than cProfile, because it has to do a lot of different worker. Because Python exposes internals to CPython in some Python modules, but they're a lot slower than just using straight C and getting straight to it. So if you're using regular Profile, if you're using it in CPython or PyPy, I'd recommend using cProfile instead, because it has much lower overhead and it gives you much better numbers that you can work with that make more sense.
Okay, awesome. So how do I get started? Like, suppose I have some code that is slow. How do I run it in cProfile?
Yeah, so the first thing that I would do is, in the blog post, which I'm pulling up right now just to see.
And I'll be sure to link to that in the show notes as well, so that if people can just jump to the show notes and pull it up.
Yeah, so one of my favorite things about cProfile is that you can call it using, the Python -m syntax, the call a module syntax, and it will print out to standard out your profile for you when it's done. It's super easy. All you need to do is just give it your, main Python file, and it'll run it. And then at the end of the running, it'll give you the profile. It's super simple, and one of the reasons why the blog post was so easy to write.
Yeah, that's cool. So by default, it looks like it gives you basically the total time spent in methods, all of the methods, looking at the call stack and stuff, number of times it was called, stuff like that, right? The cumulative time, the individual time per call, and so on.
It gives you the default, like you said, you're correct. And it's also really easy. You can give it a sorting argument. So that way you can, if you want to call it on C, how many times this is called, like if it's called 60,000 times, it's probably a problem in a 10-minute run. And if it's, it could be only called twice, but it may take an hour to run. That would be very scary. In which case you definitely want to try, you want to sort it both ways. You want to sort it every way so you can see what, just in case you're missing something important.
Right. You want to slice it in a lot of different ways. How many times was it called? What was the maximum individual time, cumulative time, all those types of things, right? Maybe you're calling a database function, right? And maybe that's just got tons of data.
Yeah, it's slow. Exactly.
Yeah. Maybe the database is slow, and so that says, well, don't even worry about your Python code. Just go make your database fast, or use Redis for caching or something, right?
Or work on your query. Maybe you can make it distinct, a distinct query, and get a much smaller data set that ends up coming back to you.
Yeah, absolutely. Yeah, it could just be a smarter query you're doing. So this all is pretty good. This output that you get is pretty nice, but in a real program with many, many functions and so on, that can be pretty hard to understand, right?
Yes. I found, so when I was working on this, I had the same issue. There was so many lines of code. It was filling up my terminal, and what I had to do is I had to save it to an output file, and that was too much work. So I was searching around more, and I found PyCallGraph, which is amazing at showing you the flow of a program, and it gives you great graphical representation of what cProfile is also showing you.
That's awesome. So it's kind of like a visualizer for the cProfile output, right?
Yeah, it even colors in the more red it is, the more hot of a call it is, or the more times it runs and the longer it runs.
Yeah, that's awesome. So just pip install PyCallGraph to get started, right?
Super simple. It's one of the best things about pip as a package manager.
Yeah, that's part of why Python is awesome, right? Pip install.
Definitely.
Whatever. Anti-gravity. So then you say, you invoke it. You say basically PyCallGraph, and you say GraphViz, and then how does that work?
So PyCallGraph is, it supports outputting to multiple different file formats. GraphViz is simply a file format for, it's a program that can show called dot files. I don't really understand how to say it out loud. So, the first argument for GraphViz is the style of how it's going to be read, the program that's going to read it. And then you give it the double dash, which means it's not part of the PyCallGraph call options. It's now the Python call that you're calling it with, and those arguments. So it's almost basically the same as cProfile, but it's kind of inverted.
Right. And you can get really simple call graphs that are just this function called this function, which called this function, and it took this amount of time. Or you can get really quite complex call graphs, right? Like you can say, this module calls these functions, which then reach out to this other module, and then they're all interacting in these ways. That's pretty amazing. Yeah,
it shows exactly what module you're using. Like if you're using regex, it'll show you each part of the regex module, like the regex compile, or the different modules that are used in the regex module, and then it'll show you how many times each is called, and they're boxed all nicely. And and it gives you, I mean, the image is so easy to look at, and you could just zoom in at the exact part you want and then look at what calls it and where and what it calls to see, how the program flows. Much simpler.
Yeah, that's really cool. And, it's something that just came to me as an idea while I'm looking at this. This episode is brought to you by Hired. Hired is a two-sided, curated marketplace that connects the world's knowledge workers to the best opportunities. Each offer you receive has salary and equity presented right up front, and you can view the offers to accept or reject them before you even talk to the company. Typically, candidates receive 5 or more offers in just the first week, and there are no obligations, ever. Sounds pretty awesome, doesn't it? Well, did I mention there's a signing bonus? Everyone who accepts a job from Hired gets a $2,000 signing bonus. And as Talk Python listeners, it gets way sweeter. Use the link hired.com/talkpython to me, and Hired will double the signing bonus to $4,000. Opportunities knocking. Visit hired.com/talkpython to me and answer the call. Because it colors the hotspots and all, it's really good for profiling. But even if you weren't doing profiling, it seems like that would be pretty interesting for just understanding new code that you're trying to get your head around.
Oh yeah, that's definitely true. That's I've employed that since as a method to look at the control flow of a program.
Right. How does these methods, how do these modules and all this stuff, just how do they relate? Like just run the main method and see what happens, right?
Exactly. It's become a useful tool of mine that I'll definitely be using in the future. I always have it in my virtual env nowadays.
So we've taken cProfile, we've applied it to our program, and we've sort of gotten some textual version of the output that tells us where we're spending our time in various ways. And then we can use PyQualGraph to visualize that, understand it more quickly. So then what? Like, how do you fix these problems? What are some of the common things you can do?
Yeah, so as I outlined in the blog post, there's a plethora of methods that you can do depending on what your profile is showing. For example, if you're spending a lot of time in Python code, then you can definitely look at things like using a different interpreter. For example, an optimizing compiler like PyPy will definitely make your code run a lot faster as it'll translate to machine code at runtime. Or you can also look at the algorithm that you're using and see if it's, for example, like an ON cubed time complexity algorithm. That would be terrible, and you might want to fix that.
Yeah, those are the kinds of problems that you run into when you have small test data and you write your code and it seems fine, and then you give it real data and it just dies, right?
Exactly. That's why they gave me the code that they gave me like 5 gigabytes of data, and they said, this is the data that we get like on a nightly basis. And I said, oh my God, this will take all day to run. So I use smaller test pieces. And then luckily I used big enough that it showed some statistically significant numbers for me.
Right. It was something you could actually execute in a reasonable amount of time through your exploration, but not so big that
I'd rather not do like C++ times of run, compile times, but at runtime, because it just kind of sits there while it's processing.
Right.
So rather not only do it once a day.
You mentioned some interesting things like PyPy is super interesting to me. We could talk more about why you chose not to use that, but on show 21 we had Maciej from the PyPy group on. Oh yeah,
I have it up right now. I'm gonna watch it later.
Yeah,
I'm so excited.
Yeah, that was super interesting, and we talked a little bit about optimization there and like why you might choose an alternate interpreter. That was cool. Then there's some other interesting things you can do as well, like you could use like name tuples instead of actual classes, or you could use built-in data structures instead of creating your own. Because a lot of times the built-in structures like list and array and dictionary and so on are implemented deep down in C, and they're much faster.
Yeah, definitely. One of the best examples of this is that I saw some guy who wrote his own dictionary class, and it was a lot slower than... And this isn't in the HumanGeo code base, just so you know. We have good code at HumanGeo.
You guys don't show up on the daily WTF?
Oh, please no, no. We're much better than that. No, this is another place that I saw some code, and yeah, I mean they have a lot of optimizations. Like in the latest Python release, they actually made the dict class. It's actually now an ordered dict in the latest Python releases because they basically copied what PyPy did the same. They did the same thing.
Yeah.
So you should always trust the internal stuff.
Yeah, and that's really true. And if you're going to stick with CPython, as you know, the majority of people do, understanding how the interpreter actually works is also super important. Mm-hmm. And I talked about it several times in the show, and had Philip Guo on the show. He did a 10-hour. He recorded basically a graduate course at the University of Rochester. He did and put it online. So definitely, I can try to link to that and check it out. That's show 22.
I'd love to see that.
Yeah, I mean, you really understand what's happening inside the C runtime, and so then you're like, oh, I see why this is expensive, and all those things can help. You know, another thing that you talked about that was interesting was I/O. Like I gave you my example of databases, or maybe you're talking about a file system, or you know, a web service call, something like this, right? And you had some good advice on that, I thought.
Yeah, I definitely. Basically, the CPython's GIL, the global interpreter lock, is very precluding. You can't do multiple computations at the same time because CPython only allows to be used at one core at a time.
Right. Basically, computational parallelism is not such a thing in Python. If you got to drop down to C or fork the processes or something like that, right?
Exactly. And those are all fairly expensive for a task that we're running on an AWS server, on an AWS server that we're trying to spend as little money as possible because it runs at like the break of dawn. So we don't want to be running multiple Python instances. But when you're doing I/O, which doesn't involve any Python, you can use threading to do things like, you know, file system, you know, expensive I/O tasks like getting the data off a URL or things like that. That's great for Python's threading, but otherwise you don't really want to be using it.
Right. Basically, the built-in functions that wait on I/O, they release the global interpreter lock, and so that frees up your other code to keep on running, more or less, right?
You definitely want to make sure that if you're doing I/O, that it's not the bottleneck. I mean, as long as everything else is not the bottleneck.
Right. And you know, we've had a lot of cool advances in Python 3 around this type of parallelism, right? And they just added async and await, the new keywords to, is that 3.5, I think it was, right? Just last week?
3.5 just came out like 2 days ago.
Yeah, 2 days ago. So yeah, I mean, that's super new, but these are the types of places where async and await would be ideal for helping you increase your performance.
Yeah, it's the new syntax is like a special case. It's syntactic sugar for yielding, but it makes things much simpler and easier to read because if you're using yields to do complex async stuff that isn't just like a generator, then it's very ugly. So they added this new syntax to make it much simpler.
Yeah, that's great. I'm looking forward to doing stuff with that. You also had some guidance on regular expressions. And the first one, the first bit I also really like, kind of like your premature optimization bit, is once you decide to use a regular expression to solve a problem, you now have two problems.
Yeah, I always have that issue. Whenever I do anything and I talk to students and they're like, and I'm like, oh, look at this text and you could do this. And they're like, oh, I'll just use regex to solve it. I'm saying, please no. You know, you'll end up with something that you won't be able to read in the next 2 days. And then, you know, just find a better way to do it, for goodness sakes.
Yeah, I'm totally with you. A friend of mine, he has this really great way of looking at complex code, both around regular expressions and like parallelism. And it says when you're writing that kind of code, you're often writing code right at the limit of your understanding of code or your ability to write complex code. And debugging is harder than writing code. And so you're writing code you literally can't debug. So you maybe not go quite that far, right?
Yeah, I think you should always try to make code as simple as possible because debugging and profiling and looking through your code will be much less fun if you try to be as clever as possible.
Yeah, absolutely. Clever code is not so clever when it's your bug to solve later.
Yeah, and I also try to give special mention to Python's regex engine. As much as I dislike regex, I think Python's read.verbose flag is amazing. And if you haven't looked into it, Python has great support for greatly annotating the regex. So if you have to use it, you can be very verbose about it, and that way it's much better documented in the code.
Yeah, that's great advice. So let's maybe talk about how you solved your problem after you, like, what was the problem? What did you find out the issue to be, and then how did you solve it?
Yeah, so what we were doing in this code is we were taking gigabytes upon gigabytes of plain text data, like words, from users of, various forums, and we processed all this data for sentiment analysis. And to do that, you need to stem each word to its base word. So that way you can make sure you're analyzing the correct word, because there's like 5 different forms of every single word.
Right. Like running, ran, all those are kind of basically the same meaning, right?
Exactly.
Yeah. Okay.
Yeah. So we get the base word of all those words. And the thing is, gigabytes of, like, let's say 5 gigabytes of words, if a word is like 4 bytes, that's like billions of, that's so many words. I don't even want to think about it. And then for every single word, we stemmed it and we analyzed it. And it was this slow, arduous process. And as I was profiling it, I realized we run the same stemming function, which is an NLTK. It's the Porter stemmer, which is amazing, and it's what everyone uses for stemming. We ran it about, in my 50 megabyte test case, which is still so many words, thousands upon thousands of words. It ran about like 600,000 times. And I was like, my goodness, this is running way too much. And there's only like 400,000 words in the English language. There's no way, each of these words needs to be stemmed, because, gamers on the internet aren't very, linguistically amazing.
Yeah, exactly.
So I figured, I can create a cache, or as it's called, in more functional, terms, I can create a memoization algorithm that saves these answers. I mean, this saves the computation, so I don't need to recompute the function, because stemming is a pure function. If you're into functional programming, you don't need to recompute it every single time you get the same input.
Right. If you're guaranteed with the same inputs, you get the same output, then you can cache the heck out of this thing, right?
Exactly. So I went from about like 600,000 calls to like 30,000. And it was an immediate, these words, like the whole program ran orders of magnitude faster.
That's awesome. And you know what I think I really love about this? 2 things I love about it. One is, you talked a little bit about the solution on the blog, and it's like, I don't know, 9 lines of code.
Oh yes, it's Python.
Yeah,
it's awesome.
And the other thing is, you didn't even have to change your code necessarily. You're able to like create things that you can just apply to your code. You don't have to rewrite the algorithms or things like this,
exactly.
Right? Yeah,
I really find that the algorithm worked. I mean, it got things done. It did it correctly. There had to be. I wasn't opposed to changing the algorithm, obviously, if that was the hot part of the code. But once I found out that the hot part of the code wasn't even code that we wrote, it was just code that we were calling from another library.
And it's probably really optimized, but if you're calling it 600,000 times, well.
Nothing is optimized when you're calling it hundreds of thousands of times.
Right.
At that point, you got to not call it that many times within that time span.
You basically created a decorator that will just cache the output and only call the function if it's never seen the inputs before, right?
Exactly. So, what it does is internally, a decorator, all it does is it wraps the function in another function. So it adds an internal cache, which is just a Python dictionary, which keeps the function arguments as the key and the output of the function as the value. And if it's been computed, then it's in the dictionary. So all it needs to do is a simple dictionary call. It's like just like 1 or 2 Python bytecode instructions, which are as opposed to calling an entire function itself, which would be hundreds of Python bytecode instructions.
Right. Yeah, that's fantastic.
Yeah. And when it when it doesn't find the answer, when it doesn't find the arguments in the function, it's just one computation, and for the amount of words in the English language that are primarily used, it'll be called much less.
Right. Yeah. So your typical data set, maybe, I don't know, 30,000, 20,000 times?
Yeah, something like that.
Yeah.
Yeah.
This episode is brought to you by CodeShip. CodeShip has launched organizations, create teams, set permissions for specific team members, and improve collaboration in your continuous delivery workflow. Maintain centralized control over your organization's projects and teams with CodeShip's new organizations plan. And as TalkPython listeners, you can save 20% off any premium plan for the next 3 months. Just use the code TalkPython, all caps, no spaces. Check them out at CodeShip.com and tell them thanks for supporting the show on Twitter, where they're at CodeShip. The other thing I like is that the solution was so simple, but you probably needed the profiling to come up with it, right? Mm-hmm. So I have an example that I've given a few times about these types of things, and just, choosing the right data structure can be really important. I worked on this project that did real-time processing of data coming in at 250 times a second. So that leaves 4 milliseconds to process each segment, right? Which is really not much. But it had to be real-time. And if it couldn't keep up, well, then you can't write a real-time system, or you need some insane hardware to run it or something, right? And it was doing crazy math, like wavelet decomposition and all sorts of stuff. Okay, this is like I was saying earlier, at the verge of understanding what we're doing, right?
Yeah.
And it was too slow. The first time we ran it, like, oh no, please don't make me try to optimize wavelet decomposition. It's kind of like Fourier analysis, but worse.
Yeah.
And I'm like, there's got to be a better way, right? So break out the profiler. And it turned out that we had to sort of do lookups back in the past on our data structures.
Yeah.
And we happened to use a list to go back and look up. And we were spending 80% of our time just looking for stuff in the list. We just switched it to
an ON.
Yeah, exactly. We just switched it to a dictionary, and it went 5 times faster. And it was like almost one line of code change. It was like ridiculously simple. But if you don't use the profiler to find the real problem, you're going to go muck with your algorithm and not even really make a difference, because it had nothing to do with the algorithm, right? It was somewhere else.
Yeah, I definitely find that there's also a lot more push, like in the Java world, to make things like final by default, to try to make them immutable unless they don't need to be. And a lot of languages are also embracing immutable by default and trying to keep as strict as possible. So that way you can, be more lenient when you need to. And I find the same thing in languages like Python, whereas I try to use a set. Unless I absolutely need a list, if I'm just containing elements, a set is much better for finding things.
Right. If you just want to know, have I seen this thing before? A set is maybe the right data structure. Or if you're going to store integers in a list, you'd be much better off using an array of integers or an array of floats, because it's much, much more efficient. You said one of the things you considered was PyPy. Just for those who don't know, maybe what's the super quick elevator pitch on PyPy, and what did you find out about using it?
Yeah, so PyPy is a very compliant Python interpreter that at runtime turns the Python code into machine code. It finds the hot parts of your code, or what's being run a lot, and it finds a better way to run that for you. So that way it'll run a lot faster than CPython, because CPython doesn't do many optimizations by default, or just in general.
Right. It runs it through the interpreter, which is a fairly complex thing, rather than turn it straight to machine instructions. Yeah.
Yeah, there's a lot more overhead.
You tried out PyPy. Did it make it faster? Or did it matter at all?
Oh, yeah. PyPy is... I actually used PyPy before even profiling, just to see, what I could, just because I was like, oh, let's just see how faster PyPy is in this case. And it ran about 5 times faster, because it figured out what to do. But the thing is that under our constraints, we wanted to stick with a little AWS instance that we were just running every night. And the thing is, PyPy uses more memory than CPython to support its garbage collector and its just-in-time compiler that both need to run at the runtime. So it uses a little bit more memory, and we didn't really want to spend that money. Whereas, because if I can get it down to an hour in CPython and it runs at 2 a.m., no one's going to be looking at that stuff at 3 a.m.
Right, absolutely. And if you can optimize it in CPython and then feed it into PyPy, maybe it could go even faster still, right?
That would have run it at about as opposed to from 10 hours to 1 hour, it'd be from if I was running in PyPy with the cache optimization, it would probably run at 30 minutes, 20 minutes. Like I said, it was unnecessary. It would have been nice, but we didn't need it. So we didn't really feel like spending the time to add that to the pipeline.
Right, sure. It seems like, if you need it to go faster, it seems like you could just keep iterating on this. So for every execution, your decorator will wrap it for every run of your Python app. But, you could actually keep those stemmed words. Yeah, it could save it to a Redis cache or to a file or to a database, or right. You could just keep going on this idea, right? But
yeah, that was definitely something I thought about doing that. Yeah, and definitely it was fast enough already. And that is where we'll go next after that. I always find that when you profile, and if you have a flat profile with nothing sticking out and with nothing that looks like it needs to be optimized, that's when you need to change the runtime. That's when you need to look into FFI or PyPy or Jython with a proper JIT.
Interesting. What's FFI?
So FFI is the foreign function interface. It's just the general term used by all languages, in which case you can drop down into C.
That's right.
Or any C-compatible language.
Yeah, that's the C. So you would basically go right in C and then hook into it with FFI.
Exactly.
That's right.
So, or use Cython, for example, which compiles Python down to C with a weirdly Python plus C syntax.
If you have to, right?
Yeah, I've never tried it, but I've seen it. And I'm you're saying you annotate Python variables with C, you say $i = 0 in Python syntax. It's really strange.
Yeah, that is strange. So, I talk about PyCharm on the show a lot. I'm a big fan of PyCharm. And they just added built-in profiling in their latest release, 4.5.
That sounds nice.
Yeah, I don't know if it's out or not. It has a visualizer too, kind of like PyCallgraph. But they said they're using something called the YAPI, Y-A-P-P-I profiler, and it'll fall back to C profile if it has to. Do you know YAPI? I've not seen this.
Yeah, I was looking at all these profiles. Also, PyPy comes with its own profiler that works on Linux called VMProf. And those are all different profiles, and I looked at them, and they're nice, sure, but I really loved how simple it was. And I got the results that I needed from C profile, and it comes with Python. It was that you didn't need to install anything, you just ran the module. And that's why I was so happy with using it and didn't need to try a different profiler.
Right. That's cool. Just Python space -m space, C profile, and then your app. Boom.
Exactly. And if you're using something like PyCharm, I'm sure, if it comes with YAPI or any other profile, definitely use that. I'm sure it's great because the PyCharm people are awesome. But for the purposes, of the simplicity that I wanted to keep in the blog post, I only used the word pip once. I only used it once to install PyCallgraph, and that's just how simple it needs to be.
You maybe could have gotten away without it if you really wanted to look at just the text output. The other thing is, this is something you can do really well on your server, right? You can go over and profile something where maybe it has real data it can get to, maybe it works fine on my machine, right? But not in production or not in QA or something and so you don't have to go install PyCharm on the server, which probably you don't want to do on, SSH'd into AWS.
Yeah, and that's why Python is amazing for being batteries included, is that it includes all of these nice things that you could need, that any developer was going to need to use eventually.
Do you want to talk a little bit about open source and what you guys are doing with open source at HumanGeo? Yeah,
so HumanGeo, we have a GitHub profile, GitHub/HumanGeo, and we mostly, most of our open source stuff is the JavaScript leaflet stuff that we've incorporated. We add themes and stuff. So if you want any map visualizations, I like it much better than the Google Maps API using Leaflet. So I'd recommend looking at the stuff we've done there. And we also have a couple of Python libraries. We have an Elasticsearch binding that we've used, which has since been superseded by the Mozilla Elasticsearch binding. So we definitely love open source at HumanGeo. and we make and use libraries in open source, and that's one of my favorite parts about HumanGeo.
That's really awesome. And you guys are hiring, right?
Oh yeah, we're always hiring. We're looking for great developers at any age, Python, Java. Like I said, we won one of the best places to work for millennials in the DC metro area.
Right. And for the international listeners, that's Washington, D.C. in the United States.
Yes, Washington, D.C.
Yeah,
Sorry.
yeah, no worries.
Yeah, whether you have a government clearance or not, we'd love, just send an email or a call or get in touch if you want to work at an amazing place that does awesome Python. I love their code bases.
Yeah, that's really cool. It should definitely reach a bunch of enthusiastic Python people. So if you're looking for a job, give those guys a ring. That's awesome.
Definitely.
So you guys are big fans of Python, right?
Oh yeah, I think they've been using Python since the company started. And I was looking at the original commits, like when the company started, and it was formed these projects, and they're all Python. It's really exciting. We've been using it since the beginning. It's amazing to rapidly iterate. It's fast enough, obviously, and you can look at it, and it's super easy to profile when you need to. That's another reason why it's amazing. It's not just like you can say it's slow, but then it's easy to optimize in that case.
Yeah, that's really cool. So are there some practices or techniques or whatever that you guys have sort of landed on or focused in on if you've been doing it for so long that you could recommend?
At HumanGeo, we make sure to, we don't go like full agile or anything. We definitely consider ourselves fast moving, and we work at a very great pace. So I guess you could call it agile. And then we have great Git practices. We use Git Flow, and we make sure to have good code review and any code base, including in Python. You got to have good code review. And when you write Python code, I do write a lot of unit tests for my code, things like that.
Nice. So is that unit test module or PyTest or?
Oh yeah, the standard library. I love standard library stuff.
Yeah, it's the batteries included, right? Yes,
definitely.
So anything else you want to touch on before we kind of wrap things up, Davis?
No, I was just I'm just really excited to be given this opportunity, and I wanted to give a shout out to all my amazing colleagues at HumanGeo.
Yeah, that's awesome. You guys are doing cool stuff, so I'm glad to shine a light on that. So final two questions before I let you out of here. Favorite editor? What do you use to write Python these days?
I'll say that for all my open source, like I work on, a website for the DC Python community, and I use Sublime Text for all that open source stuff, all my tools that I use. And when I work for a company, I ask them for a PyCharm license.
Yeah, nice.
Because it's PyCharm is great for big projects that you can really focus on.
Yeah, like I said, that's my favorite editor as well, and there's definitely a group of people that love the lightweight editors like Vim and Emacs and Sublime, and then people that IDEs. And it's a bit of a divide, but I feel like when you're on a huge project, you can just understand it sort of more in its entirety using something like PyCharm. So yeah, I like it.
My favorite thing about PyCharm is that you can like control click or command click, and you can go like on a module, and it'll take you to the source for that module. So you can really fast like look at where the code is flowing in the source.
Yeah, absolutely. Or hey, you're importing a module, but it's not specified in the requirements. Do you want me to add it for you for this package you're writing, right? Stuff like that. It's sweet.
Yeah, they have great support for the tooling and the tool chain of Python.
Yeah, awesome. Davis, this has been a really, really interesting conversation. Hopefully some people can go make their Python code faster.
Yeah, I definitely hope that they will, and I hope they learned a lot from this.
Yeah, thanks for being on the show, man.
No problem. Thank you so much.
Yeah, talk to you later. This has been another episode of Talk Python to Me. Today's guest was Davis Silverman, and this episode has been brought to you by Hired and CodeShip. Thank you guys for supporting the show. Hired wants to help you find your next big thing. Visit hired.com/talkpython-to-me to get 5 or more offers with salary and equity presented right up front, and a special listener sign-in bonus of $4,000. CodeShip wants you to always keep shipping. Check them out at codeship.com and thank them on Twitter via @CodeShip. Don't forget the discount code for listeners. It's easy. Talk Python, all caps, no spaces. You can find the links from today's show at talkpython.fm/episodes/show/28. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find iTunes and direct RSS feeds in the footer of the website. Our theme music is Developers, Developers, Developers by Corey Smith, who goes by Smix. You can hear the entire song at talkpython.fm. This is your host, Michael Kennedy. Thank you very much for listening. Smix, take us out of here.
Stating with my voice, there's no norm that I can feel within. Haven't been sleeping, I've been using lots of rest. I'll pass the mic back to who rocked it best. First develop.